Hi everyone! If you watched my last video, you saw a good example of research I did with a STEM expert, in this case with Matthew, who has served as a chemistry expert on several of my projects. I thought I'd take that opportunity to reflect more generally on why I like to collaborate with STEM experts like Matthew. In fact, he and I recently talked about this, so I want to give him credit for some of the observations that I'll share today. So, I conduct studies on how students learn with STEM learning materials. I myself have training in many fields, including psychology and computer science, but I don't have any formal training in the natural science domains like chemistry. Now, suppose I want to run a study on how first semester chemistry students learn concepts related to chemical bonding. While I think I understand the basic concepts related to chemical bonding itself, I don't necessarily know how more advanced chemistry instruction builds on those basic concepts. So, one role of someone like Matthew is to ensure that the concepts students learn are presented in a way that aligns with their purpose in the broader chemistry curriculum. And this is important because chemistry students often report feeling frustrated when later courses ask them to unlearn something they've learned before. As a simple example, they may learn a rather simplistic model of chemical bonding at first, which is then replaced by a more sophisticated model later on. Lewis structure representations, for example, are a visualization of a rather simplistic model based on valence bond theory. This had immense historical significance, and that is one reason why it's still taught today. But appropriately framing this as a simple model creates an expectation among students that they will learn a more refined model later, such as molecular orbital theory. Now, by working together, Matthew and I found that students may not always understand these framings in the way regular instructional materials present them. The ground state misconception I talked about in my last video is one such example. The question is whether instructors might even notice when students develop such misunderstandings, especially when they teach large classes or even large lectures like at our university, where you may have several hundred students in a lecture. That's one reason why I think the research I do is important to, in this case, chemistry educators. So, by teaming up, an educational psychologist like myself and a chemist like Matthew can find out how to appropriately present instruction to students. And finally, I was very happy to hear from Matthew that besides him helping me, it was also beneficial to him to work on my team. What stood out to me was that he enjoyed bringing a different perspective to the data my research team collects. Compared to other researchers on my team, he saw different things as interesting when looking at data like the interviews I discussed in my last video. To me, that again underlines the importance of interdisciplinary collaborations, because you need people with different viewpoints to understand student learning, which is a very complex issue. So, thank you again for listening today.